in the figure above, prove that A is equal to 2B. So first of all, I want to teach you a concept so that we can do this more easier. So I have a circle, and then in the middle there's a dot that represents the center, and now I'm gonna draw an arc. So I'm just gonna give it can be here, it can be there, it can be here. I'm just gonna do it here. So here, and then I have the arc, and I want to join the arc with a straight line connecting to the dot. Okay, this is obviously not a straight line. Let me do it again. Okay, let's assume that this is a straight line. Just assume this is a straight line. And then I'm going to draw another line. And then another one here. So this is called the common arc. So we have an arc, and then we draw some triangles. And in the triangle, we can see that this here is an isosceles triangle. So that means the side here, the side here and the side there are the same. So I'm just going to call this as B, and then this is B too because they're the same, so they're B. And then here, let's say this is called A, and then this angle here is C. So every time we draw a diagram, the first thing we should do is always label the letters first, because that way it will make it easier for you to do some working or estimate things. And yeah, so anyway, here in the triangle, let's say that we're going to prove that this is 180. We know that a triangle adds up to 180, so we can see that this isosceles triangle is a triangle, and B plus C is equal to 180, because this angle here, this angle plus this angle plus this angle is 180, because all these angles are in a triangle. So we have this now, and then now I want to focus on the A. So as you can see, we know that this line is a straight line, and we know that every time a straight line adds up to 180 degrees. So on the straight line, we have the angles A and C lying on the straight line. So that means A plus C is equal to 180, because A and C, they form a straight line. So do you notice any relationship between these two equations? Yes, we can see that C and C here are the same, and then 180 and 180 are the same. The only thing different is the B and the A. So what does this mean? Because B plus C is 180 and A plus C is 180. So let's just try to not think about the C and the 180. Let's just focus on the B plus B and A. So the C, we have the C there. Forget about that right now. The B plus C is 180, right? And then we have A plus C. So that means that B plus B and A are the same. Since both of them add up to C is 180, so that means both of them are the same. So B plus B is equal to A. Or you can write it out as 2B is equal to A. Now this is the concept common arc. Now that we know the common arc concept, we can do this. So first of all, let's again, in here we want to do the common arc. We want to use this common arc theory to do this, to prove that A is equal to 2B. So first of all, I'm going to draw a line again. Just like before, I'm drawing a line, and then we have the arc here. So first of all, I'm going to focus on this arc here, okay? And then I'm going to label the next thing I want to label, because labeling is very important. If you don't label, you might mess up easily because you don't know which one is which. So I'm going to label this as, let's say this is, okay, I'll use different colors. This is beta, and I'll say this is, I'll say this is alpha. So alpha is drawn like that. And then here, we know that because the arc here, just like this one, it is like that. So forget everything that is on this side. So forget everything that is here. We're only focusing on here. So just like before, here we can spot the isosceles triangle. Just like here, this is an isosceles triangle. And here is an isosceles triangle. We can see that this and this side are the same because they are an isosceles triangle. So that means that this angle here is also beta. That means they're the same. So again, just like before, again, beta plus beta plus here we have a, let's say that this angle here is called C, okay? And then beta plus beta plus A plus C, let me just do it in brackets, A plus C. So beta plus beta plus A plus C is going to give us 180. And then on the line on a straight line adds up to 180, we know that. So that means alpha plus A plus C is 180 because they're on a straight line. Again, we have noticed something different here. We can notice similar things here as well. We can see that the 180 are the same. A plus C, they're the same. The only thing different is the B, the beta plus beta, and alpha. So this tells us that beta plus beta is equal to alpha. Or you can write it out as 2 beta is equal to alpha. So now we have calculated that 2 beta is equal to 1 alpha. Now I want to do another arc. Now the arc this time, we're not only focusing on this arc, we're going all the way here. So now we're doing the whole arc here instead of just doing a small part here. So I know it may seem a bit complicated because the arc is so big, but it's still the same thing. It's still the common arc. So now we have this big arc, and now we want to find similar things just like this one. So this time we have the beta and the B, and then we have the alpha. And now I want you to just forget about the C right now. And now I want to plot new things again. Let me just plot with using, let's use red. So red represents the whole arc here. So the whole arc, this is a whole arc here, means let's say this whole arc is called P. And then the whole arc here which includes alpha and A, is called T. Let's call it T. So notice that just the arc is bigger means we have to also conclude the whole combined with alpha and A and beta and B. Before, we did not include B because before in the arc we did not include B. So now that we've included B, now it's finally time to prove that A is equal to 2B. So first of all, let's write an equation. So we know that in the common arc, the angle here is half of the angle here. So that means half of this angle here, which is P, half of P, which is 2P, is equal to T, because 2P is equal to T, and this one is 2B is equal to A. So they were very similar things. So now I have made 2P is equal to T. Now I want to include beta and B since I'm trying to prove that A is equal to 2B, not trying to solve for P and T. So I must include A and B inside. So P, if we try to make this bigger, so that means 2 times, what is P? P is beta plus B. Why is that? Because 2 and beta plus B, this one, the angle here plus the angle here and this one is P. We did this because we used the red color and we drew, and the whole angle is P. So the whole angle, which is beta plus B. So P is beta plus B. Now T is alpha plus A, because here we drew a big angle, and that includes alpha and A. So that means alpha plus A. So now I want to expand this. So 2 beta plus 2b is equal to alpha plus A. And notice that here, this is very important. 2b is equal to 1 alpha. How can we do this? We want to prove that A is equal to 2b, but it looks like we have an alpha and we have a beta. How can we remove them? So here we know that 2 beta is equal to A. So 2 beta, we have 2 beta. Let me just rewrite this. 2 beta plus 2b is equal to alpha plus A. And it says 2, and let me just use another color. 2 beta is equal to A. So let's find 2 beta here. Aha, here is 2 beta. And 2 beta is equal to A. No, alpha, sorry. That was my mistake. So 2 beta is equal to alpha. We see this 2 beta here, so that means we can substitute this into alpha. So alpha, 2 alpha, we know that 2 beta is equal to alpha. So we spot this 2 beta here. So this represents alpha. So we substitute the 2b into alpha. So alpha plus 2b is equal to alpha plus A. Now, do you notice something similar here? We can see there's 2 alpha. They're the same, so we can cross them out, and it leaves us 2b is equal to A. Now there's another way. Let me just rewrite this again. I'll rewrite this again. 2 beta plus 2b is equal to alpha plus A. Now, just now I was substituting 2b into alpha. Now I want to substitute the alpha into 2b. So what I mean is before I was substituting this into alpha. Now I want to do the opposite thing. I want to substitute the alpha into 2b. So we know that 2b is equal to alpha. And we have alpha here, so that means is 2b plus A. Now again, we see something similar here. There's 2 of these. They're the same, so you can cross them out. So that leaves us 2b is equal to A. So as you can see, they're the same. And have we proved that A is equal to 2b? Yes, we have proved that A is equal to 2b.